Your AI application is getting users, but your API bill is exploding. Every chatbot response, every AI agent action, every RAG query is burning tokens and money. The good news, most companies are massively overpaying the LLM usage. In this video, I'll show you 8 proven LLM cost optimization techniques used by real AI teams to reduce cost by up to 70% without hurting quality. We'll cover semantic caching, model routing, prompt caching, batching, token optimization, and more. By end of the video, you'll understand how to design a production-grade AI system that is fast, scalable, and cost-efficient. Let's begin. Most AI applications make one huge mistake. They send every single request to the most expensive model. Simple tasks, complex tasks, repeated questions, everything. That's like using a Ferrari to deliver a pizza. Here is what actually makes LLM cost explode. First, repeated queries. User asks the same thing again and again. Second, oversized context window. Your app keeps sending entire chat histories. Third, poor model selection using GPT-4 level intelligence for basic formatting tasks. Fourth, verbose prompt and output. Too many unnecessary tokens. And finally, lack of visibility. Most teams don't even know which features are consuming the budget. So instead of using one model fits all approach, modern AI systems use a layered architecture. Let's start with the first optimization technique. Technique number one is semantic caching. This is one of the highest ROI optimization for AI systems. The idea is simple. If user asks similar questions repeatedly, don't call the LLM again. Instead, store previous response in a semantic cache. Unlike traditional caching, semantic caching doesn't require exact matches. It uses embedding and vector similarity. So those two questions, how do I reset my password and I forgot my password, how do I reset it, can both map to the same cached response. Here is how it works. The incoming query gets converted into an embedding vector. The system compares it against previously stored vectors. If similarity is above threshold, for example 90%, the cached answer is returned instantly. No LLM call, no token cost, zero latency. Popular tools include Redis Vector Search, GPT Cache, Pinecone, and Waviat. The customer support bots, semantic cache hit rates can reach 40 to 60% that can massively reduce API spending. The second technique is model routing. This is where your system intelligently decides which model should handle each request because not every task needs a GPT-4 or Claude Opus. For example, simple classification task use lightweight models, formatting JSON, use small first models, basic summarization, cheap models are usually enough. But for advanced reasoning, coding, and agent workflows, that's where premium models shine. A routine layer analyzes the incoming request and sends it to the most cost effective model. Here is an example routing strategy. Simple task GPT-4o Mini, Cloud Haiku, Gemini Flash. Complex task GPT-4o, Cloud Sonnet, Cloud Opus. This alone can reduce cost by 40 to 70%, and in many cases, users won't even notice the difference. The router itself can be rule based, keyword based, or even another small classifier based. This is one of the most important architecture pattern in modern AI systems. Technique number three is model cascading. This is different from routing. Instead of deciding upfront, the system first tries to solve the task using cheap models. If the answer quality is low, the request gets escalated. Think of it like customer support escalation. Level 1 support handles easy problems, complex cases move to senior experts. In AI systems, the small model acts as a level 1 support. The validation steps can include confidence scores, output validation, JSON schema validation, hallucination checks, human feedback. If validation fails, the request retries using a stronger model. This approach is extremely powerful because many tasks are actually easy, so you only pay premium pricing when necessary. These techniques work especially well in AI agents, RAG systems, coding assistants, and enterprise copilots. Technique number four is prompt caching. This optimization is incredibly important for RAG systems and AI agents. Many prompt contains huge static sections. For example, system instructions, company policies, tool definitions, large language documents, multi-agent context. Normally, the model reprocesses these tokens every single request. That becomes expensive very quickly. Prompt caching solves this. Providers like OpenAI and Anthropic allow previously processed prompt segments to be reused. That means cached tokens becomes dramatically cheaper. In some cases, up to 90% cheaper. This is especially useful for long system prompts, repeated workflows, enterprise copilots, agent frameworks, etc. The key idea is simple: separate static context from dynamic user input. Cache the static portion, only send new tokens each time. Technique number 5 is context compaction and summarization. This is critical for chatbots and conversational AI. Most chat system keeps resending the entire conversation history. The longer the chat becomes, the more expensive every message gets. So instead of storing every message forever, you compress the conversation. There are two main strategies. First, compaction, remove redundant text, filler, metadata, unnecessary tokens. Second, summarization, replace older conversation history with a concise summary. For example, instead of sending 30 previous messages, the system sends the user previously discussed cloud migration challenges and preferred AWS native solutions. This drastically reduces token usage while preserving memory. Advanced AI system continuously summarize conversation history in the background. This keeps latency and cost under control. Technique number 6 is batch processing. Not every AI task needs an instant response. For example, data labeling, large scale summarization, content generation, embedding generation, offline analytics, etc. This can be processed asynchronously. Most LLM providers offer discounted batch APIs. You submit large number of requests together and in exchange for slower processing, you get major discounts. Some providers offer up to 50% lower pricing. If your workflow doesn't require real-time response, batching is a massive cost saver. This is especially valuable for enterprise scale AI pipelines. Technique number 7 is token efficient prompt engineering. This is one of the easiest optimization, but many teams ignore it. Every unnecessary tokens cost money. Verbose prompts, overly chatty responses, too many examples, massive system instructions, all of this increase cost. Here are some practical optimization. First, use structured output. So instead of asking please explain in detail, use JSON schemas. This prevent unnecessary conversational outputs. Second, trim system prompts. Keep instructions concise and focused. Third, reduce few short examples. Use only the minimum examples required. Fourth, set max token limits. This prevents runway generations. And finally, avoid repetitive context. Good prompt engineering improves both cost and latency. Efficient prompts are a competitive advantage. The final technique is LLM observability and FinOps. You cannot optimize what you cannot measure. Most companies have no visibility into which features are expensive, which prompt consume the most tokens, which users generate the highest costs, which models are inefficient. Observability platforms solve this. Popular tools include Helicon, Langfuse, Portkey. This platform track token usage, latency, error rates, cost per request, model performance, etc. Once you have visibility, optimization becomes data driven. You can identify expensive prompts, detect prompt bloat, improve routing logic, and monitor cache hits rates. This is the FinOps layer of AI engineering, and it becomes essential at scale. Now, let's combine everything into a modern production grade AI architecture. A user request first checks the semantic cache. If there is a cache hit, the response returns instantly. If not, the request enters the routing layer. Simple tasks go to small models, complex tasks enter the cascading pipeline. Static prompt use prompt caching, conversation history gets summarized continuously, background jobs use batch APIs, and the entire system is monitored through observability tools. This layered architecture dramatically reduces cost while maintaining quality. This is how modern AI products scale efficiently. So let's quickly recap the 8 LLM cost optimization technique: semantic caching, model routing, model cascading, prompt caching, context compaction, batch processing, token efficient prompting, observability, and FinOps. The biggest takeaway is this: LLM optimization is not about using one perfect model, it's about building an intelligent system around your models. The companies that master AI infrastructure will build faster, cheaper, and more scalable products. If you enjoyed this video, subscribe for more AI engineering, GenAI architecture, and LLM optimization content. And let me know in the comment which optimization technique are you most excited to implement. Thanks for watching. I'll see you in the next video.
Hey everyone! If you're enjoying the content, don't forget to like, share, and subscribe to the channel. Your support means the world to me!